Hey, Chris, you hear about the new Llama Index v0.10 release and that new LlamaParse library? You hear about this?
Yes, I sure did hear about that, Greg.
Yeah, man. It says that it can actually parse embedded tables and figures. You ready to check this out today and see if it does what it says on the tin?
I did hear it does that, yeah, and absolutely. I can't wait to dig in.
Yeah, man. Well, let's get right into it today. We'll see you back for the results and conclusions on exactly what this thing is doing for us. Welcome, everybody. My name's Greg. That's Chris, aka Dr. Greg and the Wiz. We are co-founders of AI Makerspace. And today we're going to look at one of the newest tools to hit the open source AI LLM builders market, LlamaParse. And we want to take a close look at this and see if it actually improves on the RAG for complex PDFs that we've looked at previously, and that the entire industry, really all industries, will continue to look at. If you've got questions that pop up throughout today's demo, please drop them in the Slido link that we'll throw into the chat now. But with that, let's go ahead and get right into it. We want to kind of cover a few things because there's been a lot of new stuff released from Llama Index, including LlamaParse, but also even a little bit more. So we're going to see if all this comes together to give us really a superior production grade RAG experience. As with all sessions, we're going to align our aim today and try to figure out exactly what you're going to get if you stick around with us for the hour. We're going to do an overview of Llama Index v0.10. We're going to understand LlamaParse performance on embedded tables and figures. This is what we set out to try to take a really close look at. And we're going to see exactly how to build a query engine using LlamaParse for your documents that you can leverage in your RAG applications. So first, we're going to go ahead and check out Llama Index v0.10 and LlamaParse. We're going to sort of review Llama Index RAG just to contextualize this a little bit. A lot of the docs have been changing with a lot of these tools, and we want to kind of keep you updated on the latest and greatest in the way people are communicating these tools and their capabilities. So, of course, we start with the new release, Llama Index v0.10. This is the sort of next step along with the LlamaCloud platform that was released towards making Llama Index a real next generation production ready. And we still see this keyword again here, data framework for LLM applications. Similar to other new releases we've seen, we see that Llama Index has a core that it's going to contain the main abstractions that we have talked about previously and that many of you are probably familiar with already. And the separation between the core constructs and the third-party integrations is the key aspect of the core versus the hub. Additionally, the service context object that if you've been building with Llama Index, you're familiar with, has kind of become cumbersome over time and increasingly difficult to use. It was meant to be used as an intermediate user-facing layer to let you sort of define parameters, but it's sort of become not really the best solution given this new core Llama Hub differentiation. So service context is no longer going to be part of your build if you start upgrading to the new version. And of course, the number of third-party integrations is growing. Lots and lots and lots of them, many hundreds at this point, which is really, really cool. So, this is kind of from their blog. Drop the link in the chat here. The core package underlies, and then we have integrations. We have all the Llama packs, and then there's some experimental and fine-tuning stuff happening as well. So keep an eye out for that. But the sort of the big takeaways from v0.10 are the service context removal and the core versus the Llama Hub. All right. So let's talk a little bit about Llama Index. Just in general, they've updated all of their docs as they came out with v0.10, but they still are very much a data framework. This is something that's unique in the industry, and they're focused on helping you build LLM applications that can benefit from, quote, context augmentation. This is the big idea behind Llama Index, context augmentation. Let's demystify this for a second. Let's demystify this idea of context augmentation. Well, what are we talking about? We're talking about augmenting the prompt in the context window of the LLM. That's it. We're talking about RAG. That's what we're talking about. Why RAG? Well, RAG because we don't like confident responses that are false. These are called hallucinations. Fake news. Nobody likes it. We need to be able to fact check with reference material that we can add to our prompt, augment our prompt with it, and then we can generate better answers. Now, we talk about context augmentation. One way to think about RAG that we've been communicating to our audience and that we encourage everybody to sort of break down into its core component pieces is as dense vector retrieval plus in-context learning. So we sort of see this context augmentation coming in here. So we're going to kind of walk through when you ask a question, we're going to send that question to an embedding model. It's going to create a vector format of that question after the tokenization and the embedding process. We're going to then look in our vector store. Our vector store is going to be made up of our documents. And we're going to look for similar stuff to the question using a simple similarity metric. We'll set up a prompt template that we can use to augment our prompt context. And it'll say something like, use the provided context to answer the user's query. Don't answer if you don't know. And we can then take the materials that we find that are similar. We can shove those into the prompt context window. This process is dense vector retrieval, right? We're simply using a dense vector representation, or sometimes it's a sparse dense, right? Sometimes it's a little more computationally efficient if you're using something like Pinecone that's out of the box. But let's say it's dense vector retrieval in general in a naive way, and we're returning natural language for the prompt. Now, as we set up our prompt template and we're giving it more information in context, this is the in-context learning piece. This is the big idea from the GPT-3 paper. Language models are few-shot learners. Now, together, these two things, these are RAG. These are context augmentation. The important thing to note about this setup is that it is completely independent of the LLM that you put it all into when you're done. And then the LLM provides the response in the end. So we're augmenting the context window. We're augmenting the prompt. So why are we doing this? Well, we're doing this because when we prototype, we want to make sure that we're going through the same industry standard process that everybody goes through. We start with prompting, we move to RAG, and then generally we're thinking about fine-tuning. It's not always linear, but oftentimes it is. And this sort of mental model shown by OpenAI is to start with prompt engineering. You can think about optimizing the context, what the model needs to know through RAG. You can also think about optimizing the LLM, the way the model needs to act through fine-tuning. Eventually, you'll probably do both and fine-tuning both your embedding model and your chat model in the end as you try to reach human-level performance in your application. Here's an example from OpenAI's Dev Day. So generally, we're seeing a order of operations where we're doing RAG before fine-tuning. This is generally a cheaper first step. It's going to be easier to update with the latest information, and it's going to give us that fact checkability. That's all super dope. So what you can take away from this is that, again, RAG is context augmentation. RAG is context augmentation. And note, this is all independent of the LLM. So the cool thing about Llama Index as a data framework is that Llama Index and RAG in general, they really pose no restriction on how you use the LLMs. You can, of course, go to fine tuning. You can put different things in to different LLMs, but it's really, really focused on the data piece, on being data centric, right? Because the data centric paradigm hasn't gone anywhere. And as we heard in Llama Index's v0.10 release, RAG is only as good as your data. And I like the sort of mental model, the framework that they provided in that blog of the RAG data stack. That's different from classic ETL. We're going to load the language data. We're going to process the language data. We're going to embed the language data. And then we set up our vector DB. What's interesting about this is that we load the data, we're chunking, we're tokenizing. As we're processing, we're deciding on chunk sizes. We're trying to figure out, do we need any sort of metadata or hierarchy, or how are we exactly setting up the way to think about this data, either short form or long form. As we do embeddings, there are obviously many different embedding models. You can fine tune them as well. And then the actual vector database setup, or the setup of many indices, many vector databases, and how to exactly move between them is sort of an art unto itself, especially depending on your organization's data. So in contrast to classic ETL, all of the decisions that we're taking in the RAG data stack, they affect the ultimate application. And the key pain points for people building today, this is again from Llama Index, which generally we absolutely agree with. This is what we're hearing from folks out there in the marketplace as well, is that results are sort of not right. They're not accurate. They're not good enough a lot of the time. And there's just too many things to think about, from chunk sizing to hybrid retrieval to exactly which model to if I should fine tune to all of this stuff. And it's just a lot to deal with. And then, of course, everybody has just ridiculous amounts of portable document format PDFs sitting around that they'd love to be able to use. And PDFs are famously hard for us as humans to deal with. And they've been something that's been challenging for LLMs to deal with as well. So that's where we are today. As we try to tackle LlamaParse, we're looking at this not accurate, too many parameters in PDFs, these pain points. The data syncing issue is sort of this sort of live data as it's changing and updating. This is a separate issue. We're not going to cover this today. So let's talk about Llama Index RAG tooling for a second. We've covered this previously. We're going to link a few events to you guys where we have covered it. But we essentially have a way to ingest data. Those are data connectors. We have a way to structure the data. Those are indices. Those are vector databases, which is the simplest type of index. And then there are different engines. We're going to build a query engine today. And as many of you have heard us say before, query engines are to Llama Index as sort of the chains are to LangChain. So the query engine is really at the heart of Llama Index. Now we're seeing this sort of chat engine emerge from Llama Index as well, which is cool. And that is going to dovetail directly into this idea of agents. And, you know, the data framework has data agents, because with the chat interface, you're able to sort of go back and forth a little bit better as you engage with and interact with your applications through different reasoning and different cycles of decision making. again, if you would like to know more about the constructs, we've covered this in previous events, and sort of digging in deeper to the core Llama Index package that has been sort of put together in v0.10, definitely check these out. But that's enough background for today, right? We're here to talk about LlamaParse, and it's in public preview mode, and we want to understand exactly how well it's doing, what it's doing well, what it's not doing so well, and what to expect in the future. And really, LlamaParse, at the highest level, it's proprietary, and it's a parsing algorithm for documents that have embedded objects. So we read that it had embedded table and figure capability. We wanted to check this out. It's also allowing us to build retrieval over more complex documents, sort of semi-structured, meaning they have tabular and unstructured data, meaning it's like tables and language data. And then this is all sort of in the spirit of going towards production grade context augmentation. Now, LlamaParse is built on top of recursive retrieval algorithms and work that Llama Index has done previously. So it's sort of a natural next step. That step is to parse out tables and text in markdown format, because they've built a lot of tooling already that integrates very, very well with that markdown format. So again, we can build more complex RAG systems with more complex data. Now, the sort of flagship example here from their release is the Apple 10K filings. And they did a comparison of LlamaParse versus PyPDF over these 10K filings. They also compared PyMuPDF, Textract, and PDF Miner. You'll notice that the red is where the information was not extracted very well. And so a lot of red. This was the least read amongst all of the comparisons, the PyPDF. So it was the second best. And then you'll notice there are a few red pieces in the LlamaParse one. I know you probably have to squint to look at this, but like here and here. So it's not perfect today, but it is an improvement over the standard. And that's pretty cool. Which gets us into our testing. So what we did is we said, okay, well, we want to test out if this can kind of work on, of course, the classics, right? So we picked up an NVIDIA 10K filing. We were also very interested, like, could this work on infographics? Could this work on more complex figures that were embedded in PDF documents? First, I was throwing out a couple of image ideas, but images isn't really the same as PDFs. So we found not just the NVIDIA filings, but we found a great sort of related in many ways, in sort of meta ways to what we're doing now, AI and the Future of Teaching and Learning from the Office of Educational Technology, May 2023. It's a long PDF document, 70 plus pages. The NVIDIA 10K filing is 90 plus pages. So long, chunky documents, and lots of sort of infographic-esque figures. We were wondering, can it extract the text? Can it extract the numbers? What's going on? Now, drum roll, please. Well, here's what we found. In conclusion, and we'll sort of walk you through how we got here, but we'll give you the conclusions kind of up front here, is that when it came to parsing, there was very inconsistent speed. And especially with the recursive retriever that we built, which was the recommended one that they recommended, it took actually minutes to run requests. Now, the tabular extraction, the tabular data was very good. And when it worked very, very, very well. So definitely that was the shining highlight, although there was no figure extraction. And I think this was perhaps something that we read, but then as we double clicked in and looked specifically at the release blogs, we noticed that they actually still in the process of building out better support for figures, for other document types. And of course, this is the natural progression, right? And then when you get into this figure space, you're kind of getting into the image space. So I can imagine how challenging of a problem this is. And of course, this is the kind of feedback that they're getting from lots of folks. And I'm sure that you're very interested in the day when we can do figure extraction. But that day is still not today. So how did we figure this out? Well, let's go through it specifically, and then we'll see exactly how LlamaParse is working on the back end. We used some simple models. We used OpenAI Text Embedding 3 small model, the latest and greatest from them, but the small. We used OpenAI's GPT 3.5 Turbo. We built a recursive query engine according to their recommended. We use the BAAI BGE re-ranker large. This is kind of the old two-step, right? You do embedding-based retrieval, get the docs, and then you re-rank them. And that's it. So, you know, we had the NVIDIA 10K filings. We had the Department of Ed. We used OpenAI models. We used the recommended recursive retriever. We use LlamaParse. We use Llama Index v0.10. And with that, I'm going to kick it over to the Wiz to show you exactly how this looks in code and give you a little more nuanced vibes and information related to what you might be able to expect in your application. Wiz, over to you, man.
Thank you, Greg. Yes. Okay. So we're going to go ahead and drop this notebook into the chat so you can follow along. And we're just going to go through a couple things. We're going to start with a straightforward kind of, portion of this, which is getting actual, LlamaParse to work. And then we'll move on to creating those retrieval pipelines that we saw, or those query engines that Greg was describing. So first things first, the LlamaParse release comes along with LlamaCloud. LlamaCloud has more than just LlamaParse, but for right now, that's what we're going to leverage it for. Basically, LlamaParse is exactly as was described, right? It is some proprietary algorithm that they're using. It is behind an API, so you don't have any access to exactly what's happening behind the scenes, where we can kind of infer what might be happening. But the idea is that it's an API that accepts PDFs and it returns documents, and it can return those documents in multiple formats. One of those formats is Markdown. And the power of having it return Markdown is that Markdown can help us capture these kinds of, structural relationships within our documentation. We can use Llama Index's Markdown node parser from there to help us really understand what's going on in these documents. So that's great. We also have, of course, v0.10. So this is v0.10, huge. Basically, it is exactly the same kind of thing we've seen recently from other libraries, including LangChain, which is this idea of things were getting kind of, bloated, right? We have a lot of different possibilities, a lot of different things we can do, and they were kind of glutting up the core library, and so those were split effectively. Llama Hub is now the source of truth for everything community and integration, and then Llama Core focuses on just what Llama Index is supposed to do, which is awesome. So how do we use the actual tool? Well, first of all, we're going to need some dependencies. So we're going to grab LlamaParse from our dependencies. And then we need to create a Llama API key. We're going to do this through the LlamaCloud. So I'll just zoom in some here so you guys can see it. Basically, when you arrive on this Llama Index page, we can go to our resources in the bottom left, which is our API key. And then we can generate a new key, give it a name, and then store it somewhere safe. So this is as easy as it gets. You'll also notice, I'll zoom in a lot here so you can see real clearly. You'll also notice that you get quite a few pages per day that you can use with the PDF parser. And you'll also notice that this is a PDF parser. So right now, this is only something that works with PDFs. There's no other file types that are currently accepted. And as well, we can see when we look through the code that there's only 2 return types, which is either just plain text or markdown. But you get 10,000 pages per day, which is pretty awesome. So let's head back to the notebook. Once we have our API key, we can provide it here. We'll also be using OpenAI, so we're going to slap our OpenAI key in here. And then we need to do this classic, cheat code for Google Colab. We're going to be using asynchronous functions here. There is no other way around this. We just need to run it. It's like boilerplate if you're running this in a notebook. And that's correct. Yeah, absolutely. Because it only accepts PDFs, unless your file is a PDF, you're going to have to find a way to get it into a PDF. Luckily, a lot of files are already PDFs or they're easily converted. So it should be a lower burden to convert a file to PDF than it is to convert from PDF. And that's the problem that this tool is solving. So the next thing we're going to do is just initialize LlamaParse. Couldn't be easier, right? We set up our object. We're going to say we want it in Markdown. This is because we're very keen on that structural relationship. And I'll just zoom in a little bit here. We really want to know what the structured data is saying, and we want a way to interface with it that preserves that structure, right? So this plain text idea doesn't really help us do that as well, whereas Markdown gives us notation that we can use with the Markdown node parser to understand structural relationships. Verbose equals true or false. It's up to you. How much text do you want to read? Language, there's a number of languages that are supported. By default, we're going to use English, and in this example, we'll also be using English. And then, of course, we have a number of workers. We are going to go ahead and set 2 workers because we're going to parse 2 files, right? So this is the idea. You can have up to 10 workers at a time, so you can do this kind of in batched sets of 10. Once we've done that, we're going to upload some files to our Colab instance. Pay close attention to what you're saving these as, right? So this is the file that you'll need to send to LlamaParse, right? So if I look in my files here, you can see I have done this process twice. So I have 2 different versions of the files. I need to make sure that I have the actual correct file, right, when I go to send it to LlamaParse. So please pay very special attention to this. If you've named your file something else, you'll have to take the name right from here in order for this to work if you're watching this in the future. And we do the same thing for the AI report, which Greg alluded to earlier. That's the kind of artificial intelligence report. Pretty cool document, right? It's got sweet graphs, got sweet figures. We're going to see how well LlamaParse stacks up. The next part is the actual parsing. This part's totally opaque to us. We just send the file to an endpoint, and then at some point we get back a response, and that response is documents that can be parsed easily through Llama Index, as they're obviously tightly integrated. You don't have to use Llama Index, right? The documents are just Markdown, right? So you can use whatever you'd like past this step. But obviously, Llama Index is paying special attention to their ecosystem, so that's what we're going to stay in today. Again, only PDF files. This is also a very inconsistent process, I've found. So sometimes this can take a very long time. Sometimes it doesn't take very long at all, right? Once you've done it for a file, I have found that there's likely some kind of backend caching here because each subsequent or repeated attempt to parse these files is very quick, but that first time is very inconsistent. The AI report took quite a long time to finish, whereas the NVIDIA 10K filing took much less time. So it's your mileage may vary. I would not build this into a latency critical application at this time, but for offline or batch processing, this seems super dope. Classic, we start a job, and then at some point we return into this documents, which is going to be a list, and that list is going to have these objects. We can take a peek at them and see that this markdown most assuredly preserves some context, right? There's There's no doubt about that. This is a table structure in Markdown. We definitely have some idea of structure that's being preserved, which is very important and desired, right? So that's that. First of all, that's awesome to see. We can also look at our AI report, which is it has I believe literally 0 tables. I think there's a couple at the end that are very kind of simple, but you can see it still correctly identifies Markdown, right? I mean, this is important. The idea of the Markdown being preserved is huge. And from chat, Matt is suggesting, well, we also get HTML or CSV earnings or filings, and that's absolutely true. And if that's the information you're looking for, I think that's probably going to be best. But if you're looking for a combination of that semantic information and the actual structured data, I do think that this is an excellent resource. Or in cases where you're looking at reports that don't have those examples provided as well, of which there are unfortunately quite a lot. So we can see it does the thing, right? I mean, it gives you Markdown, and the Markdown can be leveraged to understand some kind of structure about the document, right? So that's great. Let's build a query engine to see if this is actually useful, right? So we can see that yes, this is Markdown, but can this be leveraged usefully? So the first thing we're going to do is talk a little bit about Llama Index v0.10. Now, if you're used to Llama Index and you've watched some of our previous events on Llama Index, you'll remember me talking about service context, global context, setting context, all of this, right? Gone. It's all gone. Context is dead. We're all about settings now. So we still have this idea of like a global settings object that we can set so that we can fall back on specific user set defaults. But we don't have this idea of a service context that we need to pass around and manage. Instead, we're just going to do that how you'd expect normally by passing things into their constructors. So we're going to really this is probably one of my favorite changes from the v0.10, just kind of normalizing that this library to the rest of the ecosystem feels really good. But we still have settings. So we're going to set our base LLM as GPT-3.5 Turbo, and we're going to set our OpenAI embeddings as text embedding 3 small, which is the successor to Ada. It is just as good or better than Ada, and it costs less. So that's why we're using small today. You'll notice that we're using GPT-3.5 Turbo. So we're really not relying on the LLM's ability to understand the structure, right? We're really relying on the retrieval process's ability to correctly represent that structure, which is something that's a little bit different, right? If we used GPT-4 here, we might have some potential to say like, oh, well, GPT-4 is just really good at this actually, guys. Like, I don't know. It's just GPT-3.5 is good. We're going to stick with it. And then we're going to use the Markdown element parser. This is the thing that's going to, really make sure that we're squeezing as much juice as we can from these Markdown files, right? The Markdown element node parser is specifically built to parse Markdown elements, right? So we can see that we have this entire idea of how to use it. Their docs are pretty good on this. And the idea is simply that this is going to help us parse out this Markdown into the constituent parts. So those constituent parts are, what allows us to understand the structured versus unstructured nature of the data, right? So we want both. We want semantic information to answer questions about semantic questions, and we want structured data to answer those kinds of semantic questions that rely on some context that's contained within tables or figures, right? All we got to do is run this. When we run the actual get nodes from documents, you'll notice that it pretty frequently fails. This does not mean that the nodes are not created, and this does not mean that the actual total process fails. It just means that sometimes it's not able to understand the markdown that it received from the LlamaParse endpoint, and so we see some errors. It's not a big deal. This is exactly as Greg showed, right? We're dealing with a document that's quite long in both cases, right? So the idea that there's going to be a few misses is totally expected. This is a preview, their first shot on goal, but it is worth noting that there is some potential that you're going to miss, right? And when you do miss, means that we're not fully capturing the structure of our data, and that could lead to some kind of potential issues. But if we only miss sometimes, right? I mean, that's obviously much better than if we miss all the time or we miss a lot, which is the case of some of the other methods that we've seen in the past. So this is still an improvement, even if there is still some kinks to be worked out. Once we have our nodes, we're going to grab our nodes and objects so we can create our vector store index. We're going to have our nodes be those nodes plus those objects. Very important. Page number info is just in metadata. So that's it. There's nothing to it other than that. We have metadata via the nodes because we know which page we're on. So we've already captured that metadata. So that's how we're able to capture that. And we have another question in the chat that I'll just answer since we're all together right now, which is there an easy to review way? Yes, absolutely. You can tell exactly which nodes failed. It does tell you the node that had the failure. So you're able to go in and check and make sure that data is in a format that you want easily. Yes. Okay, so we've got our nodes parsed, and we accept that a couple of them didn't work out. Hey, it happens, right? This is new technology. Once we've got our vector store set up, so this is our index, right? Now we're going to create our recursive query engine. We're going to use the re-ranking process. So this is the flag embedding re-ranker, which is going to be powered by the BGE re-ranker large, right? And we're going to set up a recursive query engine. We're going to be able to install some requirements because we have to. We need the post-processor flag embedding re-ranker, and we also need to grab flag embedding from their repo. Once we install these two requirements, we can initialize our flag embedding re-ranker. A re-ranker, for those of you who are who aren't sure what that is, right? Basically, when we get a bunch of things that are likely related to our query, we have the chance to reorder the list using a more compute-intensive or time-consuming process that's more accurate, right? So you can think of it as we very quickly cast a wide net, and then we slowly look through what we've got in that net, and we take our time to reorder that list. So in this case, we're going to go from 15 retrieved contexts down to the top 5 of those 15, right? But top 5 of 15, I mean, even if the process takes a millisecond, we're still only talking about 15 milliseconds, which is not bad. It's not great, let's be real, but it's not bad. And this is the idea of a re-ranker. When it comes to our similarity top K, we're just going to grab the top 15 results, and then we are going to re-rank them. That's it. That's all. There you go. So we've set up a retrieval. We've set up our query engine. We've parsed our documents. They're all in this index now. Let's do the thing, right? So we can ask questions like, who is the executive VP operations and how old are they, right? We use the recursive retrieval engine here. So we have a number of requests that kind of parse through these nodes, which is pretty dope. You can see here. We love this. We've got that little table, right? Huge, huge. You love to see that. And eventually we wind up with this response. Deborah Shoquist is the executive vice president of operations. She is 69 years old. That's exactly right. I mean, this information is not mentioned anywhere else in the document. That's huge. If you're running this in a notebook that's on a CPU instance, you're going to notice this takes a very long time, right? So we're using this BGE re-ranker, which is a pretty beefy algorithm, right? If you're using it on CPU, this query is going to take a long time. If you're using this in a GPU accelerated instance, right, which you can select through your runtime and then go to change runtime type and then select the GPU instance, you're going to notice it's a lot faster. So just keep that in mind, that this is the slowness is not representative of Llama Index or this technology in general. It's basically just dependent on which resources you select. That's not true of the actual LlamaParse endpoint, but it is true of this retrieval process. And then we can ask questions like, what is the gross carrying amount of total amortizable intangible assets for January 29th, 2023? What a mouthful, right? Well, we're able to extract that it's 3,539 million, right? Which is exactly what we see. That's correct. And it's exactly correct. And it's right next to information that would be wrong, right? So the power of this application is immediately apparent if you're working with that structured data, right? We can see that this process allows us to very faithfully pull out the correct piece of information context. And again, this is not information that is available just through text in the document, which is important. You have to come to the table to get this information. So that's great. Let's try it on the AI education report, which again doesn't have a lot of graphs, doesn't have a lot of tables, but does have a lot of like graphs and figures, right? So let's ask about those. All of this is just resetting up the retrieval process on our actual AI report, right? And then when we query it, we can say how many AI publications on pattern recognition was there in 2020? And we get this response of there were 30.07 AI publications on pattern recognition in 2020, which is definitely wrong, right? Like it should be in the mid 50s. It should be, it should be in the mid 50s, right? But we get 30.07. Now, what's interesting to me is despite 30.07 not being mentioned anywhere else in the actual document, we do see that 30.07 is associated with this figure. So while it didn't retrieve the correct context, didn't answer the question right, we can see that it is at least able to parse some information out of this figure, even if it's not there yet, right? And I mean, this is for me the signal that things are going in the right direction, even if we haven't literally got there yet. And that's because we understand something about this. We get the right. We're landing in the right country. We might not be in the right province yet, but we're in the right country, and that's good to see. We ask another question, right? This one should be a little bit simpler. Can you describe what figure 14 is related to? And we get the response that's related to the long tail of learner viability in the context of AI and education. It goes on and on and on. This is not true. That is figure 13, but figure 14 is what we see here, which is unrelated to our response. So again, when it comes to the figures, so the more like pictorial representations or the graphs, there's still work to be done, right? Which is expected, and I think that's clearly communicated well enough in their blog content. But we would still like to see it kind of get to the point where we're able to understand better, more pictorial representations of data, as we go forward. It's clear they're working on it, but we're not quite there yet. So I would really view this more as a tool for extracting structured kind of tabular data versus this understanding of images and everything like that. So with that, we're going to send you guys back to Greg, who's going to close us out. Yeah, and take us to Q&A. So there you go.
That was rocking, Chris. Thanks so much, man. That was LlamaParse, everybody. That's where the current state of affairs is. And we are going to conclude for the day that, really out of the box, LlamaParse is a great place to start, especially in lieu of a custom in-house solution. You probably don't want to build it into a latency critical application today, but definitely it's got very, very nice tabular extraction specifically for PDFs. And again, that sort of too many parameters to tune issue that they're trying to address. They are addressing it, although it is a sort of a black box to us, the proprietary solution, which, it's not open source, but it is easier to use, as is the nature of these things as they progress. And so, if you're getting started and you're not really trying to mess with parameters, it might be a good solution for you to pick up off the shelf. Now, it could be definitely a lot faster. We'd love to see figures and the sort of pictorial representation stuff. We'd love to see other data types. Of course, they're working on it. The data framework, trying to lead the way in the industry, has a lot of work to do and a lot of good stuff ahead of them. So we look forward to continuing to check out the latest and greatest from Llama Index as they release. So with that, yes, we do have a Slido. You can go ahead and ask your question directly in the Slido. I'll ask the Wiz to come back up for Q&A now, and we'll go ahead and keep this link on the screen. If you do have questions, you can also throw them in the YouTube chat. So, Wiz, little sort of clarification here on this kind of RAG data stack is more dynamic, more complicated than ETL. Why don't ETL decisions affect the application? Was, I think, brought up when I was talking about this language from the Llama Index blog materials, where they said, hey, loading, processing, embedding, creating the vector DB, these are a situation where every decision directly affects the accuracy, in contrast to the classic ETL stack. Can you sort of explain the way you think about this, and if that's the right way that we should be interpreting this?
I would say this is a difficult one to answer cleanly, because I believe deeply in my soul that ETL decisions affect the application. I think that it's pretty clear that there's kind of different axes on which they might impact things, right? So if we're talking about performance related or latency related decisions, I mean, ultimately, it doesn't matter, because we're going to wind up with a pile of data, and then from there we can do the other stuff, right? But how we actually transform, especially, it can have significant impacts on performance, on ability to retrieve, everything like that. So I would say it's very much still worth paying attention to, and very much still a key part of the plan. Yeah.
Thank you for that question. That was anonymous, but fact checking the specific wording is very helpful for us, and I'm sure for Llama Index as well. Okay, so Vignesh Iyer asks, what is the difference between LlamaParse versus multimodal models? Can multimodal models also do this kind of OCR, including tables? And I think we sort of answered this throughout, right? It's not really doing OCR as far as we can tell. Is that right? I mean, I don't know.
Or it is.
Yeah.
We have no line of sight. So the difference between LlamaParse versus multimodal models is not understood well. They could be using a multimodal model on the back end. It seems unlikely, or it doesn't, right? The issue is that we're not quite sure what they wanted it to be able to do. We don't know what they did to create it. So I would say at this point, though, it seems closer to a PyPDF or PyMu PDF tool than it does to a full multimodal model. But that's based on I just thought of it, right? There's no there's no facts that that would lead me there. So
and we're gonna keep this discussion going with Islam here. Keep the questions coming, guys. We'd love to continue the conversation here. So Islam says in the AI ed use case, it retrieved the correct table / image, but not the correct info. Do you think we could pass the image to GPT-4 Vision, or just the image for chat Q&A?
Yeah, absolutely. Sure. Right. If we can get to the node that has the image, and we can associate that node with just literally a .ping or something like that, right? In our in whatever vector store we're using, we can build that logic in. When there's an image, send it to some kind of process that will help us understand what the image is talking about. Yes, I think that's a good thought.
Okay, cool. Let's go to this question from Sina Azizi. Sure. Can you explain your decision on the recursive query engine as opposed to, say, a hybrid retrieval, BM25, retriever?
Recursive does what we want here very well, because we're dealing with this idea of a structured piece of information, right? We kind of want to laser in on this particular part of the document, and then make sure we're able to capture the full table. Now, BM25 and kind of combining like these sparse search methods is still going to be useful, but with the recursive approach, we can more generally guarantee that we're going to get access to the full table somewhere in our context. And because that's what we need, right? And someone mentioned, or someone noted, Stephen earlier noted, right? Because we got that kind of expanded relevant context, thanks to the way that we set up a recursive retriever, we actually were able to see that it understood that 3,000 number was meant to be in millions, right? So that's a piece of context that it might not have retrieved or seen otherwise, which is why I think that recursive approach is very helpful for this specific use case that we saw today.
Yeah. Cool. I want to combine sort of two questions here. One from, they're both from Anonymous. How does LlamaParse for PDFs compare to unstructured.io? This is the last event we did. And then have you done a comparison with other open source parsers like LLM Sherpa is named here, but sort of talk about maybe, your perspective on this a little bit deeper.
The real benefit of LlamaParse is that it's integrated into the Llama Index ecosystem for me. I think that there are certainly other ways or more engineering heavy ways that you can approach these problems and custom build solutions that are better for your particular use cases. But I feel happy to say things like, I agree with the benchmarks that they've released. LlamaParse does feel better at preserving structural relationships than, say, the kind of Python packages that are meant to do this. That might not be true forever, and so the comment might not age well into the future. But as of time of recording, right, like I think it's pretty good. But the main benefit is that it's baked into that ecosystem. I would say that otherwise, there are lots of options you can explore that are going to be useful to you.
Yeah. So we've got sort of a question that kind of stacks on, some of the theories we heard earlier, or GPT-4 vision. Can we do this? Can we do that? How do you chunk PDFs containing tabular data? And maybe if I can just contextualize this with another comment, charts are the weak link. What is happening out there to see a chart and convert it into a kind of reverse prompt to unwind the data so the model can understand? Can you talk a little bit about how you think about what the best way to chunk PDFs out there is, and then what the space is as far as you can see?
Yeah, I mean, I think it comes down to, we want to have our tables preserved as some whole chunk. I mean, that's just tremendously useful, right? LLMs are good at kind of seeing or reasoning about charts, even GPT-3.5 Turbo, right? So I ultimately, I think the way we want to think about that is that charts, tables, all these kind of like figure-based elements, they're their own node, and then our text is nodes around them, and then they're connected via some kind of hierarchical metadata, where it's like, these are figures from this section along with these passages, and that's the way. In terms of like the prompt, you just feed the table in. I mean, if you just take like a markdown table and you show it to GPT-3.5 Turbo, it's going to be pretty good at answering questions about it. And if we need more, say like aggregate information, or we need derived information from the chart, you can hook it up to things like code executors or processes that are similar to GPT-4's code interpreter, where we can actually like load it into some Python structure and then do operations on it. But outside of that, I think we just want to make sure that they're their own unit, and that they're considered that, and that the relationship between them and the text around them is clear, but they're their own thing by itself, I think is very useful.
Yeah. And sort of this idea of, if you can get it into a markdown format, then you're going to be able to work with it in a lot of different ways. And okay, so then sort of kind of stacking on that a little bit. I know it's still a black box for us as LlamaParse, but a question from another one out there is, how effective is this for sort of, I interpret this as sort of maintaining the structure of the tables. Row span, column span, like, I don't know if we're talking about sort of the distance between characters here.
I mean, it's pretty good. It's just a markdown table, though. So, you know, it is good at preserving the structure of the table. It is not good at being able to, like, you would not be able to recreate the table as it appears in the PDF from the markdown that you receive. There's a 0% shot. If it was formatted in a specific way, so like things like borderless or left oriented or right oriented, all of these, or the colors, I mean, you're losing all of it. Like it's just going to show you that there's some table and that table has values and here's how they look. But that's all we're getting. We're getting zero information about kind of the way that it's visually presented, which is by design, frankly. It's not meant to reconstitute the table. It's just meant to extract it so we can turn it into something like a CSV and work with it, right?
That's right. That's right. Okay. Yeah. The great questions keep coming in. We've got a couple. Let's rapid fire these, Chris, real quick. Let's do. Can we use Llama Index for retrieval and connect it to LangChain? Is there any merit to this?
Why not? LangChain can understand Markdown just fine. Anything that can convert Markdown into some other useful file format or chunk it and convert it. LlamaParse is a great tool because it just spits out a Markdown file or it spits out a text file. And so you can integrate it into a lot of other pipelines.
All right, next, is recursive retrieval similar to parent-child retriever?
Kind of, yes.
Okay, all right. And then last question to keep up with the times here. Tariq from the YouTube chat. Is it even worth implementing RAG with these large context window models like Gemini? I mean, should we just throw it out the window?
Yes, absolutely. It is still worth implementing RAG. Period. We can talk about all of the axes, that we can examine that makes this true. Cost, effort, memory, latency, accuracy, confabulation / hallucination. RAG is still a huge, powerful component because it lets us do what we want to do, which is answer specific questions about specific things in specific documents. And the large context window is amazing, and it's going to help us do a lot of really awesome things. But for right now, those things just don't push out RAG.
And you know what? That reminds me, and I guess it's a good spot to wrap on, is this sort of idea of context augmentation from Llama Index appears to be sort of telling us that perhaps there are other patterns beyond RAG that they may have in mind for context augmentation in the future. So stay tuned for what happens next. The industry is going to continue to evolve, and we'll keep you guys up to date and up to speed on the latest and greatest. Wiz, thank you for your Q&A wisdom. And thanks everybody for joining today. If you're interested in learning about when and how to do fine tuning when you're actually sort of done with RAG, that's what we're covering next week on Wednesday live, same time. And of course, please like, subscribe, and ring that bell to stay up with all events as they drop live or ones that we upload. If you are seriously ready to accelerate your LLM application development, like seriously ready to accelerate, then check out our AI engineering bootcamp, our industry-leading cohort-based live online course where you can fill all your skills gaps from building to operating to improving LLM applications in production. If you just enjoyed engaging with us in the chat or even just watching the chat, you may go ahead and join our Discord because we can keep the conversation going in there and get you down the path to starting to build, ship, and share with us. If you are not really somebody that wants to engage, but you just want to kind of tinker on your own, we've got a few resources we want to share. One is our awesome AIM Index, which you can get direct access to code from all of our events. And the other one is our recently released open sourced LLM Ops, LLMs in production cohort 1 materials, including the entire GitHub repo. Check that out if you're trying to get up to speed. This is pre v0.1 stuff from 2023. We look forward to open sourcing more stuff as we move forward into the future. Finally, any feedback that you can provide us is great, either through Llama or through our feedback form. And as always, thank you so much, everybody. Until next time, keep building, shipping, and sharing, and we'll do the same. We'll see you all real soon. Have a great week.